Capacitors. By the end of this lesson, you should know what a capacitor's function is and how voltage and current behave in a capacitor. What does a capacitor do? A capacitor's job is to store charge. By storing charge, it stores energy. Capacitors can be used in timing circuits and electronic amplifiers. A capacitor symbol looks very much like the symbol for a cell, but the two lines are exactly the same size and width. When current flows, charge is stored on one of the plates. Here you can see a buildup of negative charge on the right-hand side. Electrons that would have existed on the left-hand side are then repelled by electrostatic repulsion of the electrons built up on the right-hand side. The electrons are repelled away, leaving a positive charge on the left-hand plate. Current will continue to flow in a circuit so long as the capacitor is charging, but if the capacitor becomes fully charged, no current can flow because the electrons have been all repelled away. Current stops flowing and the capacitor builds up a potential difference. When it's reached full capacity, the potential difference is equal to the potential difference of the battery. In this way, the capacitor stores energy. Capacitors and charging. A capacitor is considered to be charging when charges are flowing onto one of the plates. As charge flows, the voltage or potential difference across the capacitor begins to increase, but in a very unusual way. It increases, but as the rate of increase gets smaller and smaller and smaller, until the voltage or potential difference starts to level off, so it's at a constant or consistent value. This voltage is the same voltage as the battery voltage, or EMF. When measuring the current flowing through the circuit, the current decreases, but again in an unusual way. The current rapidly decreases at the start and then gradually decreases towards the end until finally the current stops completely. At these points, the capacitor is fully charged. No more current can flow. When current flows onto a capacitor, charge is built up on either side. As charge is stored, it becomes increasingly more difficult for more charge to be stored on the plates. The capacitors become filled, and electrostatic repulsion starts to take place between particles such as electrons. Current altogether therefore stops. This is the reason why the two graphs follow the curved shape that they do. Capacitors and discharging. When a capacitor discharges, it releases the charge that it had once stored. As charge is lost, the energy it once stored is also lost. The voltage rapidly decreases at the start and then gradually decreases towards the end until it reaches zero. When charging, the current flowed in one direction. When discharging, the current flows in the opposite direction until the capacitor is finally discharged and current no longer flows. Because the current flowed in the opposite direction there, the graph has to reflect this, and it starts in the negative end of the y-axis. Here you can see the current starting off at a negative value because it's going in the opposite direction. There is a rapid decrease and then gradually decreases towards the end until finally it reaches zero again and the capacitor is fully discharged. To review the learning intentions from the start of this lesson, we now know that a capacitor's job is to store charge, and as it stores charge, it stores energy. We've also taken a look at four graphs. We have looked at two graphs of voltage and current as the capacitor charges, and we've looked at two graphs of voltage and current as the capacitor discharges. You will need to remember these graphs.